Hello everybody, welcome or welcome back. In today's video of 10-minute series, we'll be covering single line diagram of power system structure. If you're ever curious how does your society or your home get power, this video will make you get good clarity, make you understand how, from where, all those stuff. So let's begin without further wait. So let's start. So first I'll explain you by basic structuring. There's something known as generating structure, generating stations. There's something known as generating stations. And these are located far away from the cities. They're located far away from the cities. So generating stations have generators which basically convert mechanical energy to electrical energy. And if this mechanical energy is converted to three-phase power supply, then that is known as alternators or synchronous generators. Then those generators are known as synchronous generators. If the mechanical energy, if machinery converts mechanical energy producing three-phase AC supply, that is known as synchronous generators. If you use only one of these, very less power supply will come. So they will be connected in series and parallel, series, parallel combination to get desired output. Okay, and these generating stations can generate 6.6 kilovolt or 10.5 kilovolt or 11 kilovolt supply. Next, moving on to sending end substation. So after generating station, you have to come to sending end substation. Here, whatever 6.6 kilovolt or 10.5 kilovolt or 11 kilovolt is there, we use here very important step-up transformer to increase the voltage to say from 11 kilovolt to say 220 kilovolt or 132 kilovolt or even 110 kilovolt. Let me brief you. You have to remember these values, if not all, at least a few. For exam purpose, this generating station will generate 6.6 kilovolt or 10.5 kilovolt or 11 kilovolt. That will go to the sending end substation where step up transformer is used, and that is usually it becomes it's not getting small step up like 33 or something. No, directly 220 kilovolt, 132 kilovolt, 120 kilovolt. Like this step up transformer is used step up the voltage. But exactly why is this happening? You have to understand one thing. Before that, you have to remember, you have to forget actually this V equals to IR. While learning this Ohm's law, we were always telling V is exactly proportional to I. But remember, this was when R was constant. So this formula is not applied over here because you might get confused. But V is directly proportional to I, so why is this happening? When I say ahead, you might get confused. So I'm telling you in advance that don't mix this formula up. So basically, why are we using step up transformer? It is basically to reduce the I square R losses. Look at this relation now. We know P equals to VI. This formula is also quite well known. Now V is equals to P by I. This formula clearly shows that if you increase V, I will decrease. So that to decrease I, why are we decreasing I? Because if I is less, then I square R is also less, obviously. Imagine, if I is 100, this is what? 1, 2, 3, 4 times of resistance. If I is just 1, then it is just 1 R. So if I is less, then this I square R is also less. and this I square R is basically loss, power loss. So power loss is less, means what? It's good only. So less current, less power loss. That's why we're using step up transformer to step up the voltage. And this is one advantage. One more advantage is that less current is flowing, so the diameter which is required for this less is only sufficient. It is economically sufficient and efficient also, because current capacity is less only, which it is flowing. So diameter is also less is enough. That is the two reasons. So now what did we see is that generating station was there, which was developing 6.6 kilovolt or 10.5 kilovolt or 11 kilovolt, correct. Now that was going to sending end substation, where it was getting step up transformer 6.6 kilovolt to 220 kilovolt or 132 kilovolt or 110 kilovolt. Now this will undergo, by the way, correct, this will undergo primary transmission to reach receiving substation, not receiving end substation, it is just receiving substation. By primary transmission it is reaching receiving substation. Here what happens is that step down transformer is used. Whatever 220 kilovolt is there, it becomes 33 kilovolt. Not again here step down transformer, it is not becoming just less from 220 to 33 directly kilovolt. Okay, 33 kilovolt or even up to say 66 kilovolt it can come. After receiving substation, this is going to go through secondary transmission and it's going to reach secondary substation. Here again here also step down transformer. Here also step down transformer is used, whereas 33 kilovolt is going to become into 11 kilovolt or 6.6 kilovolt. This is known by secondary transmission. Now again the secondary substation, from secondary substation where is it going to go? It is going to again undergo step. By the way, this 11 kilovolt whatever we got, this is directly going to go to big consumers who require 11 kilovolts to operate their big machineries. It will go to them. Otherwise, this can also undergo step down distribution by step down transformer. This is by primary distribution. Again by step down transformer, this 11 kilovolt, if it becomes into say 230 volt, that is for single phase, and if it becomes into 400 volt, not kilovolt, okay, 230 volt, or that is for single phase. For 400 volt, that's for 3 phase. Okay, this is secondary distribution. That's it. So what, I'll just brief you once again. First we had generating stations, which was giving us a voltage of 6.6 kilovolt or 11 kilovolt or 10.5 kilovolt. This was going to sending end substation. Here what was happening? Step up transformer was used. I have given you the reasons: reduce I square R losses, all that I have told. Generating station, mechanical energy, electrical energy, if it's going to go with AC 3-phase AC, then synchronous generator, all that I have told. Now which step up transformer, what's going to happen is that 11 kilovolt whatever was going, that's going to become 220 kilovolt or 132 kilovolt or 110 kilovolt. Now that is going to undergo primary transmission and it will go to receiving substation. Here it will undergo step down by step down transformer. This 220 kilovolt whatever was, that's going to become 33 kilovolt or 66 kilovolt. Now this by secondary transmission will go to secondary substation, where again by step down transformer this 33 kilovolt whatever was there, it becomes to 11 kilovolt or even 6.6 kilovolt. Now this 11 kilovolt will directly go to big consumers by primary distribution, or this if 11 by secondary distribution, and by using step down transformer this 11 kilovolt is going to become 400 volts. That is going to go to 3-phase power supply. If it's going to become 230 volts, or if you make it go to 230 volts, that's going to go for single phase power supply or AC system, right? Then that is going to go to consumers like us. That's it.